Hello, I just wanted to show you how to do number 7 on your worksheet. It says, if the girl in the previous question holds the gun tightly against her body, the recoil speed is less. Explain. Okay, now the system is the girl, the gun, and the bullet, and the girl has a mass of 48 kilograms, and there should be a new recoil speed. Cool. So now the girl and rifle are like one system together. So you got the girl, who's also part of the rifle, because she's holding on to it, and then you got the bullet. Okay? So let me clone this. After the collision, it's really an explosion. The bullet will be moving to the right, and instead of just the rifle moving to the left, it's the rifle with Kim, with the girl. So the mass has now changed. So as far as explanation, the mass of rifle was 2 kilograms, I believe. But now, mass of Kim is added to that, which was 48 kilograms. So it's like the rifle now has a mass of 50 kilograms, which is a dramatic difference from 2 kilograms, right? So there's the bullet moving to the right. There's Kim plus rifle moving to the left. There's the bullet. This is Kim plus rifle plus bullet. All right? And just like before, since the velocity is 0 before the collision, the momentum is 0 before the collision. So this is before. You probably never thought of it this way, but an explosion is just a type of collision. Oops. So after the collision, you've got Kim and the rifle moving to the left, the bullet moving to the right. The total momentum before the collision has to equal the total momentum after the collision. Right? And since the total momentum before is 0, that means the momentum of Kim plus rifle, that vector has to add to the momentum of the bullet such that there is no resultant vector. You add these vectors together and you get 0. There's not a vector you get when you add those vectors together. When you place them head to tail, it's a never-ending loop that goes forever. So that means that the momentum of Kim plus rifle, the magnitude of that momentum has to exactly equal the magnitude of the bullet's momentum, right? And it's very similar to the previous problem. It's just now we have a different mass. So now we want a mass of 50 kilograms. And we don't know the velocity, the recoil velocity of Kim and the rifle right now. So we're going to look for that. I'll write it in blue. And the muzzle speed of the bullet didn't change. The mass of the bullet didn't change. So the muzzle speed is still 150 meters a second. and the bullet still has a mass of 0.001 kilograms. So velocity of the rifle, recoil velocity is going to be 150 times 0.001. I'm going to leave the units out to make it simpler. Divided by 50. So I can do most of it in my head right here. Just velocity of the rifle is equal to, what's that, 3? So it's 3 times 0.001, because 150 over 50 is 3. So the velocity, and this is going to be in meters per second. What's 3 times 0.001? I don't know. I should know that. 3 times 0.001. Yeah, that's what I thought it was going to be. It's 0.003. So that's a dramatic difference. Wow, what did I just do? Let me fix that. What was it again? Oh, it was 0.003 meters per second. So that sure is a lot less. And, you know, you won't find me on a shooting range, but I suppose if you observe people shooting guns, holding on to the gun tightly would probably be a good idea, and making you part of the gun as opposed to holding onto it loosely, in which case it could fly back and hit you at a pretty big speed. Anyway, I hope you enjoyed the video, and have a good day.